Hi guys, welcome back to the channel, and if you're new here, welcome to the channel for the first time. We hope you enjoy the videos. Today is a really special video for me because we've just hit 2,000 subscribers on the channel, and so it's a little bit of a celebration, and I wanted to share with you some of the work that I've been doing for the last week or so. If you're new to the channel, hit that subscribe button, hit that bell notification and smash the like button, and then you'll get some more videos from us coming soon. Hope you enjoy this video. Sit back, relax and enjoy the show. Forgive me, it had to be done. So the first job this week was actually installing two-way switching in someone's garage. So they had a garage that was attached to the house. There's obviously the front garage door which opens up to drive the car into, but there was also a back door that comes in from the utility room of the house to enter into the back of the garage. Now by that back door they did have a switch to turn on the fluorescent light in the garage, but they didn't have a switch for the light to control it from the front of the garage door. So when they came into the front garage door they couldn't turn on the light, they'd have to walk all the way to the back of the garage to turn on the light switch by the utility room door. So what they asked is that I could put in a two-way switch so that they could control the garage light from either the front garage door or the back garage door, whichever one that they were coming in from. So what I did is I ran it in surface mounted PVC conduit, and it was a metal clad two-way light switch that I installed, and I'm going to show you a few clips to see how I did it. Talk about a little bit about two-way switching as well and how that works, the method that I used, and put your comments below of how you might have done it, if you might have done it a little bit differently. That's the first job of the week. So here's the new two-way switch that I've installed. Metal clad two-way switch, surface mounted, and you can see here I've got a 3-core and earth cable coming into it, 1mm 3-core and earth, and this is how I've connected it. So I've got the brown into the common, black in L1, grey in L2, and both the black and the grey are sleeved with brown sleeving to show that they are live conductors. And I've just looped the earth wire through there, through the back box terminal and into the front plate terminal so that everything's earthed properly. So the question is, how did I connect it at the other end? Well, I've run it along in this black PVC conduit up along the top corner of the garage there with a couple of little sets over a couple of little obstacles, and metal clips obviously every so often to stop the cables from collapsing in the event of a fire. And it runs along here, 90-degree bend in the corner, another 90 to turn down, and it runs down to the existing metal clad switch, which was just a one-way switch, or it was connected as a one-way switch with just a twin and earth cable going from the light fitting to it. And here's my 3-core that I've run in. So how to connect it so that you can now convert to two-way switching? Well, currently the red conductor was in the common terminal and the black was in L1, and that was just acting as a one-way switch. But you can see the switch here, it is a two-way switch, so it's got an L2 terminal as well. So we're going to convert the system to being two-way. So what we have to do is put the red in L1 along with the black conductor of the 3-core, put the black in L2 along with the grey conductor of the 3-core, and then the brown from the common just goes all the way through to the common on the other side, and that way it will work. And this is what we can call the conversion method of two-way switching. So it's where you're converting from one-way to two-way, putting a 3-core in between the new switch and the existing switch. And there you can see my cable run in the conduit all the way along. So it's an easy method to do, worked well, and all in all I was quite happy with how the job turned out. Managed to do it fairly neatly in the black PVC conduit. And when you're testing two-way switching, you have to test all combinations just to make sure it works okay. So you have to do one switch, then the other switch, then go back to the first switch, and then back to the other switch. All 4 combinations. Then you know that it works correctly and you've not made a mistake with the wiring. And that's it. Two-way switching, done. So once I'd finished the two-way switching in the garage, the customer asked me also to install an extra double socket in the kitchen next to an existing double socket that they had in place. They had basically one double socket above the worktop by the fridge, and they had loads of stuff plugged into it. So they had all these extension plugs, you know, the sort of block type plug with 3 plugs that can go into it. And then they had their phone chargers strung across and loads of stuff going on. It was a real mess. So they said, can you install us an extra double socket next to this existing double socket? And then they said, oh, actually, could you make it a USB double socket so that we've got 2 USB sockets to actually install our iPhone chargers or whatever into as well. So I did that, and what I had to do is chase out the wall next to the existing socket, sink in a metal back box, and then spur the new socket off the existing double socket that was on the ring. So here's a little video of how I did it. Next was chasing out the wall to put in this additional double socket. So on the left we have a double socket here which is on the ring circuit, and next to it I've spaced a new double socket, and I use my Makita SDS with a chisel bit, a scotch comb chisel bit, to chase the wall out and fit the socket neatly within. So we chase it out, we hoover away the dust with the vacuum cleaner, and then we fit the metal back box, which you can see here. And the front of the metal back box has to be flush with or slightly recessed behind the wall. Then I use this marking tool to just mark the holes, creates a nice fluorescent mark at the back, and then it makes it easy to drill the holes. So then I use my 5.5mm drill bit with my Makita drill just to drill the holes for the back box. These bricks are quite hard actually, so chiseling away at it took some time, but at least they didn't crumble away too much, so I managed to get a fairly nice neat chase, although you can see the plaster crumbled away at the bottom there, which was a bit annoying. But yeah, that's one of those things. Unfortunately it does happen, sometimes you can't avoid it. Let me know in the comments if you've got a way of chasing out really neatly so that the plaster never crumbles away. I would love to know what you do. So just drilling out these fixing holes now, and then once that's done I can put raw plugs in them, fix the metal back box
into the hole. I'll just hoover out that dust first, and then I'll make a hole in between the existing box and the new box and put a piece of 2.5 twin and earth cable in between, and then I can connect those up, fill around the edges to make it look nice and neat, and then all the customer needs to do is do a little bit of decorating, just do a little bit of touching up with the paintwork afterwards. So what I'm doing here is just filling around the edges roughly with my one hit filler that I keep on the van. I get it from the wholesaler and it's a great one because it just dries quickly. It can be easily sanded down. I'm just filling in all the holes and little gaps around the edge of the metal box to make a fairly neat finish. And then I'll leave it to dry for about half an hour while I go and have my lunch. And then when I come back, I'll just sand it down a little bit and put the socket face on, and then just do a little bit of finishing touches around it once the socket face is on to make sure it all looks nice and neat and flush. But this one hit filler is really handy. I always keep some on the van because you never know when you might do a little bit of damage when you're putting up a light or fitting a socket, and you just need to fill in a few little holes or smooth things off a little bit. And it's white, so sometimes you can get away with putting it in and the damage is not even visible. People don't even need to paint afterwards because it's white rather than putting in sort of brown polyfiller or something like that. So I'm quite happy with this product. I use it quite a lot. If I can find somewhere you can buy it online, I'll stick a link in the description for you. So now here it is, the finished product. I've put the socket face on, connected all the wiring, and as you can see, looks fairly neat. It does need a lick of paint and a little bit of sanding around the edges, but they're both nice and level with each other, and with a bit of paint you'll never know. And obviously I put a new socket face on as well, on over the old socket so that they both match.
The next job I came across this week was a real weird one. I got called out by a letting agency to go to a rental property where the tenant said that their electric shower was not working and needed rewiring. So I thought, okay, this should be interesting. What am I going to come across? I got to the property and they had a brand new electric shower that had been installed. Now, interestingly, it wasn't a power shower where the electricity heats up the water. It had both a cold and hot water feed to it, but it was brand new, still had the plastic, the sort of sticky plastic protection film over it, but they said it's just not working, there's no power to it. And actually what they said was that British Gas, they'd called them out to have a look at the old shower. British Gas recommended replacing it with a new shower. Then they came in to replace it, and then British Gas said to them, oh, the wiring is not safe, you need to get it rewired. So they installed the shower, but they said you're not allowed to use it, it's not safe, don't turn it on. But either way, I got there and this is what I found. I'll show you some pictures. Basically there was no power at all going to the isolator switch itself. They had this 50 amp Crabtree pull switch on the ceiling for the shower, which probably then it used to be the kind of shower that heats up the water with electricity. So incoming you had a fairly heavy cable to supply it, but then outgoing it was wired in yellow Arctic type flex, you know the stuff, flexible cable, yellow sheath. I think it was 1.5 millimeter, something like that, going out to wire this shower. Anyway, the whole thing was dead. So it was really weird. Went down to the consumer unit, everything was turned on, all seemed okay, and actually there was no dedicated shower circuit. So this was a bit weird. So I sort of puzzled around, and eventually I found a switch fuse spur that had some labelling on it from the landlord or whoever it was previously who'd helped wire it up. And it was on a little switch fuse spur, but then it had this massive thick 6mm or 10mm cable going out to the shower isolator from that, and then this fiddly little flex cable going to the shower. So it was a really weird setup. Anyway, the whole lot wasn't on RCD protection. It had an old Crabtree consumer unit with no RCD protection for any of the circuits. So what would you do in this situation? Put your comments below. What I did was I informed the tenants and the agency that it wasn't safe to reinitialize the circuit because there was no RCD protection, and I recommended that they have a full EICR carried out on the property because frankly the way stuff was wired up in that place, it just looked really weird, really dodgy. A lot of DIY clearly had been going on there, and so an EICR would be the first call, and probably the result of the EICR will be upgrade the consumer unit, get RCD protection put in, and rewire parts of it because it all looks like a real mess. So that was the next job that I did.
So here's the shower, as you can see, brand new, plastic film still on, and here's the isolator switch with the yellow flex going out of it and a 6mm twin and earth cable coming in to supply it. All very bizarre because the incoming cable had no power to it. Here's the consumer unit, and although there was one circuit that was turned off, which has water heater, it was actually nothing to do with that, it was just the immersion heater. And all the power was outgoing. And here's the shower that British Gas fitted, along with the isolator switch, which is a 50 amp proper power shower switch. Interestingly, in one cupboard I found this, which said it was the isolator switch and fuse for the ensuite shower. And it was turned on, but the fuse had blown. So that was why there was no power going to it. But it was still not safe because there was no RCD protection and the wiring looked really dodgy. So I recommended an EICR, and we'll see what they want to do after that. This, it seems, is one of those landlords that loves to label everything up and go over the top with their labelling. And this always rings alarm bells for me because it suggests that probably they wired the place up themselves and did the instructions themselves too.
The next job I did was doing some remedial work on a commercial property after having done an EICR. And a couple of the main jobs were replacing RCDs. So there was a main 300 milliamp RCD protecting the whole property, which had a fault or just didn't work properly. It didn't trip when you pressed the test button, so I recommended replacing that RCD with a new one. And there was also a 30 milliamp RCD in a sub consumer unit which protected some socket outlets. That had the same issue. Test button pressed, it didn't trip. So I replaced that as well. I also did some investigation because there was a break in the live conductor on one of the ring circuits. So I had to take off a load of the socket outlets and try to find where the break in the ring was. And I also had to put some blanks in the consumer units because there were blanks missing, and so live parts were accessible to touch. So that's some of the remedial works I did. I'll show you a few photos. Let me know what you think in the comments. There's one particular thing that you'll notice which I hadn't come across before, and it puzzled me slightly. There was the 3-phase and neutral tails going into a metal distribution board, and they drilled individual holes for them. So immediately alarm bells started ringing. Eddy currents, this could be a problem. But then as I looked closer, I noticed that there were little slots that had been cut in between the holes. So in effect, it created kind of one large hole, but it was just a very small slot that was notched in between all of the holes. Now, I'd never come across this before, and I didn't know if this was acceptable or not. It seems to kind of make sense that it would minimise the eddy currents possible in the situation, but I wasn't sure. So I texted a friend who does a lot of commercial EICRs, and he told me that actually that is a snag solution that is put in the NIC EIC book, Snags and Solutions book, to solve the problem of eddy currents when bringing in 3-phase and neutral tails into a metal consumer unit. So that was quite interesting. I learned something new. It still seems a bit dodgy to me. It just looks a bit dodgy. Let me know in the comments what you think about it. But when I looked at it, I thought, I can't really see any other way of getting around this, any way of doing it better. You know, you could drill one large hole and fit one big compression gland and put them all through it or something like that, but that wouldn't really be nice either. So I couldn't really see a nice way of doing it better. Let me know in the comments if you think of a nice way to do it that I haven't thought of.
So here's the incoming supply, and this is the dodgy RCD that we're talking about, which doesn't trip when you press the test button. But up above, where the tails come in, this is what I'm talking about. Eddy currents? Not sure, because they've cut a tiny little slot in between each hole. Let me know in the comments what you would do if you came across this. If you've got any solutions, I'd love to know. Now you see here the distribution board had blanks missing. So one thing I did was fitted a few blanks. And here's the new RCD that I put in. So I put in this new RCD, and I put in the blanks into the consumer unit to solve those issues. This RCD was also broken, so I fitted a new RCD there and fitted some blanks in the consumer unit as well. And here's the broken ring circuit. As you can see, the wire had completely pulled out. So I repaired that. That was a quick fix. And fortunately, it was only the third socket I checked, so it didn't take me too long to find, which was nice.
The next one was a little bit puzzling as well. So I got called out to a customer who had bought a new washing machine for their property. They were renting the property. They bought this new Bosch washing machine, looks very nice, very expensive. And as soon as they plugged it in and it got to the wash cycle, the motor kicked in, it tripped the RCD. So they assumed that there must be a problem with the washing machine itself. So they sent it back. Bosch delivered a new one. They plugged that in. Can you guess what happened next? It tripped again. Same problem. So they called out an appliance repair engineer. The appliance repair engineer came out, checked the washing machine, checked the socket, plugged his polarity tester in or whatever, couldn't find any problems with the wiring. So he said, it must be the washing machine. The washing machine must be faulty. Send it back. So they sent the second washing machine back. And they got a new one delivered. Now they're on to the third brand new Bosch washing machine. Can you guess what happened next? They plugged it in again, and exactly the same thing happens. As soon as it got to the wash cycle, the motor kicked in, the RCD tripped. And so by this time, they were just really suspicious and they didn't really trust the appliance engineer's opinion. So they called me. And I said to them, okay, no problem, I can run some thorough tests on the circuit and figure out what's going on. I said to them, probably it's a faulty RCD, but we'll only know when we do some tests. So I got to the property, and upon looking at the consumer unit, it was quite an old MEM consumer unit with all MCBs, apart from this one circuit which the new washing machine was plugged into, which was on an RCBO, and it's one of those 2 module RCBOs that these old MEM boards have. And so looked okay, pressed the test button, it trips alright, plug my tester, my Fluke multifunction tester, into the socket, polarity's okay, did an earth loop impedance test, earth loop impedance is okay. Then thought, okay, I'll do an RCD ramp test. So I did a ramp test. Ramp test was okay, it was tripping about 21 milliamps. Did a RCD trip time test with all the different phases, half times, 1 times, 5 times, 0 degrees, 180 degrees of the phase. Everything was fine. It acted just as it should. So I took the cover off the consumer unit, and then I found that the functional earth tail had not been connected. So I thought, aha, that's it, that's the problem. It's obviously not functioning properly because the functional earth tail's not been connected. So I stripped that back, connected the functional earth in, plugged the washing machine in, gave it a go. Guess what? It tripped again. So by this time I'm starting to despair, because I'm thinking, well, what other tests can I do? How can I figure out what's going on? So I got my clamp meter, put it on the earth for the circuit to check if there's any weird things going on, like DC leakage current or anything like that. Got them to run the washing machine on the cycle. No DC leakage current appearing with my clamp meter. There just seemed to be no explanation for it. So what I did was I got an RCBO from a Hager board that I had lying around in my van, and I sort of did a Jim will fix it type bodge job kind of thing, just to get it working, because it didn't fit properly into the consumer unit. But I rigged it up so that the circuit was now wired off this Hager RCBO. And I just thought, well, we'll try it. We'll run it with a brand new RCBO from a different manufacturer and just see if it works, see if it trips or not. Turned it on, ran the washing machine, and it ran absolutely fine. So I'm still not sure what the problem is with this RCBO that's existing, but there is a problem with it. And putting in a new RCBO will solve that problem. The difficult thing is that these old MEM boards, they don't manufacture the RCBOs anymore. Luckily, my uncle owns an electrical salvage business, and he happens to have some in stock that I can use to swap over. So if the customer goes ahead with the quote that I've given to them, then I can buy one off him and get it fitted. Link in the description, by the way, to my uncle's business. A little shout out to Uncle Phil, who owns Circuit Breaker Specialist. He's got stock of thousands of different circuit breakers and RCBOs of all different types, shapes and sizes. So if you ever get stuck and you need a retrofit RCBO, MCB, whatever kind of circuit breaker you might need that's a little bit special, a little bit unusual, and rather than changing the whole board, you just want to get one that fits, Uncle Phil will sort you out. He's probably got what you need. Go to Circuit Breaker Specialist and he'll sort you out. So that was the next job that I did.
So here's the consumer unit. Nothing particularly untoward about that. You can see that RCBO in the middle. And as we take the cover off, well, it all looks nice and neat, but wait, something's not right. Can you see it? The functional earth is not connected for the RCBO. That was a red herring, unfortunately, because that was not the problem. It turned out it was this RCBO that was faulty. So I will be probably replacing that with a new one supplied by Uncle Phil from Circuit Breaker Specialist.
Another job that I've been busy with this last week or so was a consumer unit change for a domestic property out in the countryside, where they had an old consumer unit with one 30 milliamp main RCD that was tripping intermittently. Now they called me out to see if I could figure out why it was tripping, and you guys know the story. This has happened to me before. A few weeks ago I made a video about avoiding nuisance tripping. Well, it was the same story. Basically, loads of electronic devices running on this one RCD, and all the leakage current was messing with the RCD, so it was just tripping at really random and odd times. So I recommended for them to replace the consumer unit with a new one, an RCBO consumer unit. And as it was a TT system with an overhead supply and they had lots of electronics through the house, I recommended for them to get a surge protection device installed as well. But the tricky thing was, it was in an airing cupboard at the top of the stairs. And you know what airing cupboards are like. So you've got the hot water tank, then you've got a couple of shelves or whatever, and it was tucked right up just near the ceiling in this airing cupboard, and it was really awkward to work into. So I had to sort of get my step ladder up against the immersion heater tank and then hop in and sit on one of the shelves while I was working in this little cramped space, beavering away changing the consumer unit. Anyway, I managed to get the consumer unit changed over, and I got an email from the customer today saying that everything's great, it's not tripped at all since I've changed the consumer unit. So he's really happy because he works from home and he needs his power to be working consistently. And obviously things are a lot safer and more convenient now. If there are any faults in the future, the RCBOs will trip and he'll only use one circuit, lose one circuit rather than losing the whole lot. And the surge protection device is so important in a TT system where you've got an overhead supply, because I've had several customers in the past who've had problems with the overhead cables shorting out and creating surges. One customer, it blew up all the electronic devices in their house. It nearly burnt down the house because all the electronic devices started smoking. It blew the circuit boards in the boiler, it blew their Nest thermostat, it blew all their laptops up. So you can see why the regs are demanding that we put these in now when it is necessary, because of, you know, the value of electronic goods that could be damaged. And in this case it just made perfect sense to put one in while I was changing the consumer unit. I didn't have much space though, because it was quite a narrow space that I had to fit the new consumer unit, so I couldn't fit an integral Hager SPD within the consumer unit that I put in. What I had to do is put the surge protection device next to the consumer unit on one other side next to the meter, and I put one of these Wilex ones in, which Wilex do, where it's got a main switch isolator and then an SPD next to it. They're quite nice, neat little units, really easy to install. That's the second one I've installed now, and I was quite pleased with it. And it's quite good because it serves as a means of main isolation for the whole system as well if you need it. You just put it in line with the tails. So I'll show you a few pictures and little videos of the job, and let me know in the comments what you guys think.
you.
That's the UPS. I don't know if it's maybe. Are the sockets this plugged into definitely live? Just on the off chance that they've wired them off some other random. Oh, it's not plugged in?
Yeah.
Oh, well, there you go.
That kind of helps.
I was going to ask earlier and I thought, no, I won't do that.
I will blame you because it was unplug everything.
That's it. It's my fault.
It's your fault.
Oh, well, that solves it then. That's good.
That's fine.
And here it is, the finished product. So a couple of things I did take on board from other electricians recently is this fire filler stuff to put in the back. Still not sure if it's 100% necessary, but I did it anyway. Not really happy with the finish. It looked a little bit messy, but at least it's fireproof. And here is the SPD that I was talking about, Wilex, with a built-in main switch. Nice and easy to install and looks pretty neat. And there's my cheeky little grin, trying to stick my head out of the cupboard. And here it is with the cover on.
If you enjoyed this video, as always guys, smash that like button, hit subscribe and smash that notification bell for more great videos coming soon. Thanks for watching.